Hello, everyone. I'm Ted Schock, and I'm here to present Chrome for Android 101 today. I'm going to go ahead and get started. I apologize if my cat comes into screen. He's just here to help. So the project started in earnest in mid-2010. I've actually been on Chrome for Android since starting in 2011, so about a decade. Go away, cat. So it started with an internal dog food build. We're building on gingerbread, but that never shipped. Hey, buddy. Hey. It started as a closed source fork. So we were changing really everything in Chromium at the beginning, and we were just trying to get a product out there. Undoing that process was painful and slow, so I would very much not recommend that path if you can avoid it. And finally, we publicly launched in February 2012. So some general ideas about the product. There are a lot of users. We have over 1 billion users on Chrome for Android. The majority of our users are up to date, so they're either on the current milestone or the milestone behind. But there's a long tail of older versions that do trail off. A lot of people get a phone and then never update. We support 7 Android versions at this point, everything from Lollipop on. And we have a large proportion of devices that have 2 gigabytes of RAM or less. So these are often Android Go devices or similar. And I'm going to just say that like device capabilities really vary drastically. You have devices that have more RAM than the laptop I'm presenting on, and you have stuff that's down to 1 gigabyte. In addition, we have very diverse screen sizes. So we have phones, tablets, foldables now, phablets. And while the majority of our devices are phones, we have to support and scale across all of them. And I checked recently, and there's over 100 OEMs that we support. In addition to diverse devices, we actually have very diverse users as well. So the bulk of our users are actually emerging market users. And that's something that has been a shift over time. In addition, there's challenges around usage patterns and device capabilities, and really just browser expectations. What a user here needs from a browser versus what a user needs somewhere else can be drastically different. And many of our users these days are mobile first, which really means they have no desktop computing experience. And often they have no previous browser experience. So they didn't go with 20 years of learning a browser. This is their first time, their first exposure to the web. And then it's even compounded with that. We have drastically different digital literacies. So you have people that are very quick exploring, and then you have people that are very hesitant and kind of worried and just very like scared of what clicking on a link might do. So how do you scale across those? In addition, there's some differences that Chrome for Android has versus the other Chrome ports. So we don't support extensions. We are a single profile, yet incognito still exists. We do have all 4 public release channels. So we have Canary, Dev, Beta, and Stable. And it's at a 6-week release cycle, which is what Chrome uses. But the Android OS calendar still really matters for us. We are a system app, so we need to make sure that we're ready and installed and ready to go. So we often have to deal with that and juggle our own release schedule accordingly. There are many entry points into Chrome. It's app icons, it's links, it's widgets, it's notifications, it's shortcuts. Basically, users find new ways to open Chrome, and we just have to be tolerant and kind of know that it's going to happen in ways that we often don't expect. When I mention links, those come in by view intents, which is just Android's general link handling system. And those happen from external applications, and a lot of traffic originates from those. So, and that can come from search, WhatsApp, really anything. But when you think about Chrome for Android, there are really 2 primary modes you have to think about. There's the tabbed mode, which is really what we consider the browser. It's what you see when you click on the Chrome app. And it's the one that, as I alluded to, there's a lot of expectations of what that should be doing. Should it be behaving what a browser has been, or does it need to be what a browser needs to be for someone that's never seen a browser before? And how do we handle both of those? In addition, there's also something that's very prominent, which is called Chrome Custom Tabs, which you'll see abbreviated as CCT for short. These are built on custom tabs, which is part of the Android ecosystem, which any browser can implement. And these are really focused on an optimized experience for loading a single page very fast from another application. It allows them to do some theming, add some additional capabilities, and is really focused on allowing them to, the app developers to control and give a really curated user experience. And there are a lot of users that only use Chrome through custom tabs. So it's something that is very important to us and something that we need to continue prioritizing. In addition, there are a couple other ways of launching Chrome. There's web APKs and TWAs and PWAs, and just something to think about. So web APKs are a way for us to wrap a progressive web app, also known as a PWA, in an APK. APKs are really the executable format for Android. And by doing that, it allows PWAs to be first-class citizens of the platform, which means they show up in the all apps list. They have notifications attributed to that app. You can attribute the resource consumption to that app. And it really does show up on the home screen in the all app list in a way that you would expect a normal app to be. Then there's a new thing called TWAs, I guess it's not that new anymore, that really is enhanced full screen custom tab experience. And really that allows you to list that experience in the Play Store. And that makes it where app developers can have an even more curated experience. And now I'm going to jump into generally like what you should think about as a developer focused in Chrome for Android. And a lot of this is general kind of best practices for Chromium in general, not just Chrome for Android. As you might expect, we write a lot of our code in Java and C++. We share as much code as possible with the other platforms where we can. But because we have those two different languages, we often use two different IDEs, and the most popular ones these days are VS Code for C++ and Android Studio for Java. There will be Markdown files in the Chromium codebase that talk about the best ways to set those up and develop. It does require a Linux environment to build. And I want to emphasize that emulators are your friend here. They're a way to test phones, tablets, different Android versions very easily without needing like a cabinet full of devices, and which is what I used to have. And when you're starting to look at it, when you look at the general code architecture, if you're familiar with Chromium, hopefully you've seen the anatomy of a browser talk that's going on right now. If not, you should watch it. There's the content layer, the Chrome layer, Mojo, surfacification, all of these things that we have done for Chromium apply to Android as well. But often there is a Java counterpart. Then you have things like tab model, window, compositor, and those mean different things on Android. There's the big thing that to call out is that we don't use browser.cc or browser. So that is a kind of a big entry point on desktop that we do not take advantage of. And when you look at the UI, we build that with Android platform widgets and views. We do use a little browser side compositing. So if you go to our tab switcher, you'll see that's actually using browser side compositing. So a modified subset of the CC layer in Chromium. And we use minimal web UI. We don't use web UI for the new tab page, for example. And we do not use Chrome's views, which is the general desktop way of rendering. So this is some general code pointers. Again, this is definitely not meant to be exhaustive. But if you're looking for where Chrome Android, the app is, you should look in Chrome/Android. I will highlight that that is not the desired thing long term, but that's a place to look today. Then you have Chrome browser Android, which is the C++ counterpart to the above. Then if you want to look for some building blocks for starting to build UI, look for Components browser UI. It's a good place to see what's capable and available to build with. And when I mentioned the content layer before, Content Public Android is our Java content API. So that's where you'll see web content, navigation history, things that are needed to build a multi-process browser. If you're looking for build specific things, like build Android is where our build toolchain comes from. And finally, check out base Android when you start building a feature. That's where there's general utilities for JNI, tasks, callbacks, scheduling in general is available there. And really when you're looking for anything, look for an Android directory, look for _Android files, and you can also look for Java files. That's a pretty good giveaway that this is for Android. So I mentioned previously that the bulk of our code is in a single directory, and that's causing a lot of problems. It means that a lot of the code ownership is centralized to a few people, including myself. and it's difficult to reuse parts. It's really difficult to test things in isolation. So we've got a large effort to try to break that up. So if you're adding a new feature, try not to add to Chrome Android. Really try to add to a feature-specific directory that you can own. It's something that will give you more ownership and not need to bother people like myself. And again, it's not a bother. I do like to help, but you often find that you have a lot more ownership that way. So I really do encourage that. So some entry points to look at when you start trying to dabble around in Android. When I talked about the tab mode browser, in code, look for Chrome tabbed activity. Activities are Android's just general windows. That's the thing a user sees. So if you look for things named activity, it's a good indicator that that's a pretty high visible surface. For custom tabs and TWAs, they both use custom tab activity. And for web apps, it's web app activity. And finally, I pointed out our Android manifest. The Android manifest really defines your public API. Things in this file are going to be visible to either the system of Android or to other apps on the system. So you need to be really careful about things you add there, and more explicitly, things you remove there. If you have something that's marked as exported true, and then you remove it, you're very likely to break Chrome. If a user had that surface open and then the app updates, then that thing might not be there anymore, and it's going to be a really broken experience. Or there may be someone that has actually dependent on that, and you may be breaking them. So be very careful about adding and removing to that file. Again, we should be doing it. It's thoughtful, but just be doing it with purpose. And as I mentioned, we write in C++ and Java. That's great, but what happens when you need to talk to them across the boundary? And that's why you use JNI, which is the Java native interface. And this is, again, high level. We have a bunch of build magic that tries to make this easier for you. So if you want to call from C++ to Java, you annotate your Java methods with called by native. And if you want to call from Java into C++, you define an interface with the @natives method and define all of your methods inside of that. And that allows you to bridge into C++. You add a bunch of this build magic to your GN file, and it will auto-generate those bindings for you. And it allows you to make those API calls very seamlessly and, again, very effectively. Again, some gotchas to consider about. When you have these two different languages, you really do need to aim for clear ownership. So Java either needs to own the C++ file or C++ needs to own the Java file. When you have mismatched dependencies or one outlives the other in a weird way, it causes a bunch of problems. Finally, something to consider is C++ is not garbage collected. So if your Java object created the C++ object and then is garbage collected, you have now leaked that C++ object. So in Android, you'll see that we actually lean towards having clear destruction paths in Java, where we don't often rely on a clear garbage collection alone to clean things up. So you really need to convince yourself that you don't need an explicit destroy call instead of letting it bite you later when you realize you've been leaking a bunch of data. And we do have some helpers around like user data akin to C++. We have the activity lifecycle dispatcher that lets you watch when an activity goes to the background so you can clean things up. So we have things to help you control this. Another thing to consider is that when you pass the JNI boundary, you're often duplicating the memory. It often can't be shared. In particular, bitmaps are a painful one. Is when you pass the bitmap over, we reallocate it in Java and then copy the pixel data over, but it doesn't share the pixel memory. So this means that when you're passing that object, you temporarily have 2x the memory. And that can be very painful if you're using bitmaps very often. So if you're using bitmaps in Java, then try to have the cache of them in Java if you have a cache at all. But if that's been a problem for us, is where there was a C++ cache for desktop that then we were actually marshaling over and hitting that memory. So be careful about that. Think about that when you're doing it. Again, here's a README file for more information about the JNI generator. Again, just a primer. This one's a bit of a painful one to talk about because it makes me sad as a software engineer. But mobile development is really a trade-off of best engineering practices. We have to make sure that we're keeping things small and efficient, but maintainable. And that can be a bit of a struggle where you often have to do things that feel a little gross, but it's because you really do want to keep the overall binary as small as you can. So be careful about too many abstractions. Don't have interfaces of interfaces of interfaces with single implementation. Be careful with lambdas. They often generate a class file. So if you end up having the same lambda multiple times, you define it multiple times, you've created 3 classes. So instead, create the Lambda once and pass it in 3 different places. One that's kind of a quirk is that we use int defs instead of simple enums. Enums have a generated class file as well, and that is something that is not needed for most cases. Most times it's just a simple list of ints, and that's where an int def is preferred. But if you have an enum where you're using actually complex business logic and you're doing things inside of it, enums are totally fine. And finally, code written is not the code that is run. While I do say be careful with abstractions and things like that, we run a bunch of this through Java optimization that inlines a bunch of things, combines methods, classes where it can, so it makes it where it does get as small as possible. It can't do everything, which is why we can't rely on it alone to kind of make up for everything that we could be doing differently. That markdown file is very useful. It tells you about how to figure out what line of code became what line of code in the final binary and how you can test that. So you're starting to do some UI. This is some general best practices about your UI design. The one that I want to emphasize as much as possible is just keep your UI as dumb as possible. Really try to make it where it can run in Android Studio outside of Chromium. Like that is the goal. So we do not have direct dependency on C++ and try to limit your dependencies on Android framework, widgets, or other Chrome UI helpers, but really not the rest of the big Chrome machine. Our UI is built on a modified MVC pattern, which I'm going to go to in the next couple slides. But there's a markdown here that kind of gives you an overview. It's very, very helpful to try to figure out what we actually mean there. And finally, this overview markdown file for UI development on Android provides a lot of helper links to general Android like starter guides. It'll talk to you about application and activity lifecycle. In particular, that's one that I really do emphasize everyone to know. Look at how events are dispatched. How does drawing happen? What's an invalidate versus a request layout? Those are the things you want to learn about before you start writing Android UI. So this is our MVC pattern. It's MVC-ish, and it really just focuses on isolated testable components. So we have a coordinator, which is really the public API of your feature. You have your mediator, which contains all of your business logic, and that's the thing that listens for signals kind of from the big Chrome blob that can update a model. So your model is the thing that, again, is your source of data and truth for the UI. We have some helpers that listen for changes to the model. They talk to a view binder, and the view binder is basically just a pair. It changes from a model and update a view. But it makes it very beneficial that if you want, okay, I want a list here versus a carousel, often you can just switch out the view binder and the view, and you've got a completely different thing. The model stays the same. The mediator doesn't really care. And it's very, very beneficial. Allows you to test your UI just as a standalone UI component, lets you test your mediator without actually spinning up the UI. So it makes your test small and focused. And as you're thinking about it, when I mentioned the coordinators are your public API, it means that coordinators are the only things that should talk to other coordinators. You shouldn't have a mediator talking directly to another coordinator, and it should be that your coordinator is a tree. It sets up its dependencies, it knows how to connect them if needed, and from there. So your public API, pass in dependencies, be explicit, the way we do UI development at a high level. Please read the markdown file for more information. And this is just general best practices for doing feature development. Again, the one that I want to emphasize as much as possible is put it behind the flag. We have a lot of good flag infrastructure in Chrome and Chromium in general, and really design your feature to be enabled and disabled and enabled and disabled many times. So something that would be very bad is, oh, I'm going to enable my experiment. I'm going to change this database schema, and then, oh, it's disabled and everything's broken. So you have to make sure that things can be gracefully rolled back. As I mentioned before previously about in our modularization slide, really aim to have your code in a feature-specific directory. Have it with its own owners file, its own build GN file, its own deps file, everything that where you can have that sense of ownership. You're doing that triage yourself. You can maintain it. You don't need to ask for other reviewers and owners to help. Test function. And even for us, 70% is well for test for 0. With that, we make sure that we can test it over time. You can move to a different effort and everything's great. So I think that's something that we are now holding ourselves to a higher standard for. For Googlers, there is a process called FastPath++, which allows you to ship outside of the 6-week window if you have super good test coverage, you've got a bunch of things met. So I do recommend looking at that as well. Okay, so you've been developing code, things are kind of working, and now you're starting to get bugs. And you got to sit here and take a step back. Is this a bug in Android? Is this an OEM bug? Is this a Chrome bug? Like, how can I diagnose this? And I want to emphasize Android will have bugs, just like Chrome will and does. I've introduced many of them. So if you're sitting here banging your head against the wall and you can't figure out where the source of the bug is, if you think it might be in Android, build a small sample app using Android Studio. Testing something inside of a big app like Chrome or any Chromium browser is going to be really painful. So do that. You can make a min reproducible case, and then you can get for feedback there. The Android source code is open source. So cs.android.com allows you to look at all of the Android source code. So if you think something weird's going on, look at the source code. I'm often got view open or activity to understand, as I mentioned before, okay, which way does this view dispatch happen? Which observer is called first? Things like that. And that's been very, very valuable. When you sit there and think, okay, I can reproduce the bug, but does it reproduce on every OS version? Maybe it's a bug that they found in Lollipop that was fixed in Marshmallow. So you've got to sit here and see, okay, maybe there's a support library here that can help me, that can wrap this call that handles these quirks, or do I need to handle it myself? And does it reproduce on every OEM? As I mentioned, we have hundreds. And they have the ability to change the Android framework. They have specific drivers, anything that can cause quirks and unexpected behavior. So it may be a device-specific thing. Finally, again, it very much could be our bug. Like, again, Chrome definitely could have a bug. You can use debuggers. You can use log-based debugging if you need to. There's many different options in Chrome. Again, something I want to emphasize aggressively, because it's bitten us more times than I'd like to admit. There is no such thing as a clean shutdown for Chrome. It doesn't happen. So Android doesn't use swap memory, doesn't utilize it. So instead, Android, the framework, just kills processes when it detects low memory. And we have some control, but little. As a result, we can keep really only a few renderers alive on like desktop. And on low-end devices, we guarantee only one. So when you're designing a feature, understand that if you needed a bunch of renderers, like that could be. Currently, the Chrome process overhead, every renderer has a 16 to 16 megabyte overhead, depending on OS version. We're certainly looking at that, but it's something to also consider. So some gotchas: really expect every file you write to be corrupted. Handle it gracefully, understand it's going to happen, and it will happen. We recently got bitten by something where our tab model got corrupted and did wonky things. Save periodic snapshots. Don't wait till Chrome is backgrounded to save data. Save it periodically. Don't clean up caches only on shutdown. Also do it lazily on startup to make sure that happens. Again, the browser process never is cleanly shut down. It is only killed by Android. So don't try to do something in a destructor of profile, because that won't happen. So make sure you're doing cleanups as needed. And activities can also be killed, so don't rely on memory in state alone. Some performance considerations, as I mentioned, using more memory means we have fewer tabs alive. So we're more likely to be killed by Android. So use memory when you need it, when the user's interacting with your feature, and then clear it aggressively. Try to keep the code small. Binary size is important, not as critically as it once was, but it's still very important. The more Java code we add, it means more memory, and the slower the startup. And read this Android tip for more perf tips. Some more performance considerations. Don't do things more often than needed. Running too often wastes battery, wastes data, anything that's bad. Look at the background task scheduler to make sure that you're doing things as needed when appropriate. Be careful about running things on startup. Cold startup happens a lot. And that's where we're starting the browser process for the first time. So don't do things on startup that can wait till after the first page load. We have something called deferred startup handler that allows you to in-queue tasks, but make sure that, is this more important than the user actually getting to the page you want to do first? And that's what you should think about. Be careful about Android API calls, especially synchronous ones. They may be hiding a remote IPC, they're triggering a different application to load, or they're triggering disk writes. So be very careful about what you do and what you do there. This is where reading the Android source code is very valuable. Don't do any IO on the UI thread ever. Don't do it on Android. Don't do it on any Chrome port. Really just be very cautious of running any long running tasks on the UI thread. We have post task and async task to handle these things. So if you're worried about it, do it that way. And finally, we do have strict mode. We do have strict mode enabled. We'll try to catch the most egregious cases, but it will not catch everything. So building, high level overview. We use different things on different versions. We use APKs for local development, but we use bundles, which allow the Play Store to do some magic to give just the bits the users need. We use that on later versions. We do a combined WebView and Chrome for a couple version called monochrome, and we use trichrome for the current versions of Android. So this is just something that gives you what to look for, what's the output, and which version do we use it on. I do recommend looking at the build instructions marked down at the top. And finally, bit of testing, please add them. There's good testing docs in Chromium, so look there. JUnit, you use that for doing small unit tests. It runs on the host environment on your Linux box. And RoboElectric allows you to mock out some Android interactions. They're fast, they're reliable, use them. Instrumentation, again, Java-driven, runs on the device, larger integration tests, runs the app. They're often flaky, so use unit tests where possible. But if you're writing them, write batch unit tests. I include a link there. It allows you to run it without restarting the processes constantly. We also have a dummy UI activity test case, which allows you to test UI without spinning up the browser. Also very valuable. Then we also support browser tests, which is a C++-driven browser integration test. The thing to clarify here is that it's very similar to the one on desktop, but we run completely different test suites. The same name, different test suites. And then there's gtest, which is how you write your C++ unit tests. Runs on the device. It's based on Google's C++ testing infrastructure, and it can be shared across platforms. So please write tests. This is hopefully try to give you a brief overview of Android development in general. Hopefully there's some links you can look for. Most of it is in the source code itself or in the repository. So look there. Now I can take a few questions. I can try to get my cat back.
I don't see any questions, so Mark, you can go ahead and screen share.
Okay. It sounds like we're going to switch over to iOS. So thank you for anything. And if you find something that is broken on Android, please reach out. We'll try to fix it better, and let's try to make the documentation and the source code as best as we can. Thank you.
All right, thanks, Ted. My name is Mark. I'm a developer.
Stand by 1 second.
The best place to ask Android questions, you can ask them to Chromium Dev. There is also Java at Chromium, so if they're general Java questions, that is a useful place to do that too. Okay. All right, back to Mark.